I'm Tim Ventura, and we're joined today by Colonel Eric J. Felt, commander of the Phillips Research Site and director of the Air Force Research Laboratory Space Vehicles Directorate at Kirtland Air Force Base in New Mexico. He leads a team of over 1,000 personnel who comprise the nation's Center for Excellence for Military Space Science and Technology, Research and Development, as well as Advanced Technologies Integration and Demonstration. So Eric, welcome. And let me start out by asking about your background and what led you to your current role with the AFRL Space Vehicles Directorate.
Thank you, Tim, and I am thrilled to be here with you today and talk about this exciting time in space and the exciting work that's going on at the Air Force Research Lab. In terms of my personal background, I've got my academic training is in electrical engineering, bachelor's, master's, and PhD. And then I went into the Air Force, and my first part of my Air Force career was in flight test. And I was a flight test engineer that tested the F-16 and the airborne laser out at Edwards Air Force Base. And then I had the really important moment in my career when I had an assignment to the National Reconnaissance Office, which is that builds our nation's spy satellites. And what I learned while I was there was just how important and exciting space is as a place where we can provide capabilities that really help our nation's warfighters deter conflict and support conflict when they have to engage in it. So at the NRO, there's kind of when I got excited about space, and ever since then I've been doing space acquisition work until I got to this dream job here really at Air Force Research Lab Space Vehicles Directorate.
Absolutely. Well, and I can imagine I would definitely call that a dream job as well. And so I want to jump right in and ask about the big shakeup this year, right? Which is the creation of the Space Force. I'm wondering what are your thoughts on the Space Force and what role do you guys have in supporting it? And does that change the nature of what you're doing over at the Space Vehicles Directorate at all?
Well, first of all, I think this is the most exciting thing that has happened in my career, certainly on active duty. And it's exciting because it just shows how important space is and how we're really opening up new opportunities to do new things in this domain. And I'm really glad. It was certainly not a new idea to create the Space Force, but I'm really glad the political forces finally aligned and allowed it to happen last year. And it caught a lot of us kind of by surprise because we've been talking about it for so long, but I don't know if anybody actually thought it was going to happen anytime soon. And then all of a sudden, here we have it. And so it's really exciting and important. I think the nation and really within the DOD and Congress, they realized that if we lose in space, then we lose, period. And that was a really important, Renaissance moment, I think, in the thinking that led to the stand-up of the Space Force. And so that's why we have to have a service where the people in that service wake up every morning thinking about space and how are we going to make sure that we deter conflict in space and maintain our nation's space capabilities to the best possible extent. And so it's been quite a whirlwind 9 months so far, and we're just coming up on the 1-year anniversary of its creation. Now, in terms of what AFRL's job is, our job is the same as it was before in that we have to maintain the technology pipeline to deter conflict in this domain. And that's what we were doing before, but now we just are doing it for an elevated customer, which is this Space Force. And what we're trying to do is deter conflict by maintaining this technology advantage, both tonight and in 10 years. And especially, I'm very focused on 10 years from now, making sure that I put the right enabling, widgets on the wall here for the Space Force to have available to them to always have the latest game-changing thing and the latest thing that can make sure we are not technologically surprised by our adversaries and that we're able to maintain our capabilities when we need them the most, which would be in a high-end conflict like they talk about in the National Defense Strategy. So, in that sense, in terms of the technology we work on, it hasn't been a change, but organizationally, it's been an immense shift in the last 9 months and really in an exciting way.
Well, and it's interesting that you mentioned that. The organizational change has been tremendous. And along with the creation of the Space Force, there's also a vision for space power that USSF Chief General Raymond outlined supporting both multi-domain operations on Earth as well as defending American interests in space. And so I'm wondering, what is your vision of space power, and how does that fit into our existing doctrines?
Yeah, I really like that. That is a wonderful document, capstone document that came out this summer and created by a lot of energetic captains and younger folks that had spent a lot of time thinking about this domain, and then, refined and blessed and released by General Raymond and the Space Force leadership. I was really pleased to see that document, because it's the most forward thinking in terms of what our strategy needs to be. And really, to me, that's a guiding light for the technologies that I need to enable the kinds of things that they talk about in that document. In the Navy analogy is there's a blue water Navy and a brown water Navy. And the blue water Navy is far out at sea, making sure that we protect the sea lines of commerce and make sure that we're able to engage with the enemies out far at sea if we need to. But then the brown water Navy supports the terrestrial operations, the coastal operations, and the land operations close to land. And it's the same in space. And that was really, I really noticed that concept when we did a competition for our next flight experiment here at AFRL in the spring. And we started out with like 27 different concepts and ideas, and got those matured down through an internal accelerator and other methods down to the end, when we had, and the two leading concepts at the end were, one of them was total blue water. It's like, how are we going to take care of space domain awareness at the moon? And then the other one was total brown water. It was, how can we use very low Earth orbit to better support our terrestrial war fighters and be integrated into the joint fight? And we got to the end and we're like, man, how can you choose between blue water and brown water? You can't. You have to be able to do both. And that really came out in General Raymond's document that he put out on the doctrine that we have to support. And so we are doing both. We selected both of those as our new flight experiment for that reason, just to support his vision.
Oh, okay. Actually, and that was my next question, was how you guys are supporting this vision for space power. So it sounds like you have kind of a two-pronged focus then. You're both supporting Earth-based, the multi-domain operations where the other forces are involved, as well as this blue water role where that's like lunar and cislunar and things like that.
Yes, that's exactly right. There are some commonalities to those different visions. In particular, AFRL tries to be very focused on 5 to 15 years out. There's tons of organizations that are responding to urgent needs and delivering stuff in a year or two, and we do some of that. But we are the main organization chartered with the thinking of how do we maintain this tech edge 5 to 15 years out, and that's really what we're trying to do, whether it be for the blue water or for the brown water. And then the other part of our secret sauce that's common to both of those is just that we maintain some organic expertise and capability. We can do some of this stuff ourselves. I mean, I have the labs and the people that can build satellites to go to the moon or to very low Earth orbit and do the mission that they need to do there. And that is something that really helps us, not only when we execute organically, but when we go out and contract with contractors and partners, etc., which is how we still do most of our research. But having a little bit of organic capability, that's AFRL's secret sauce.
Yeah, and you guys have a large role and a large scope of role too. I mean, so the primary mission areas here include space-based intelligence, surveillance, reconnaissance, as well as navigation and communications, and as well, like including space domain awareness and defensive space control. So how do you support across such a wide domain of areas? I guess that would be kind of an interesting question.
To me, it's a system engineering problem. All right, we have we take this national defense strategy as kind of our guiding light, and then it's like we go area by area, and we say, okay, what are the potential game-changing technologies here? How can we apply those technologies to the kind of high-end conflict that's specified in the national defense strategy? And what that drives us to is a couple of things across all the mission areas. One is resilience. All right, we are very focused on making sure that those capabilities that our nation has come to depend so much upon are there when we really need them the most, which is when an enemy is trying to deny your use of those. So one of my number one focus for the last 2 years at least has been on resilience of these capabilities. So for example, in the GPS is very easily jammed. It's a wonderful capability, but very easily jammed. So we have a navigation technology satellite 3 program that's meant to be, we joke that it's China beating PNT, because it will work even when somebody's trying to deny your use of that particular GPS spectrum or waveform. So that's just one example, but then across each of those mission areas, trying to do new things that are going to be really valuable to the DoD and to deterring conflict in space. In the ISR area, I'll just, a couple other examples are, over the past decade, we've explored hyperspectral imaging and hypertemporal imaging. So hyper means, splitting it up into thousands of bins, and so hyperspectral means splitting the spectrum up into thousands of bins, and that actually enables some really neat characteristics in terms of determining material properties and stuff that you can't do with traditional ISR, and that was successful. We did that in the early part of this past decade, and then just this past 2 years, we flew the hypertemporal payload that shows that by sampling very fast in time, you can actually see missile plumes through clouds, which sounds crazy, but the physics actually works, and we've proved out that is a new phenomenology in ISR in space. So just those are a couple examples, but the basic idea is in each mission area, go in there, find out what the art of the possible is, and then find out how we can best maintain our tech edge in that area and contribute to the warfighting capabilities.
So would it be fair then to call what you guys doing like kind of the Space Force labs then? Space Force laboratories? And I guess I should also ask how you work with DIU, DARPA, the Space Rapid Capabilities Office, SMC, and a lot of these other organizations that need some of what, like you mentioned, is the organic know-how, I guess, and the cutting edge technology development.
Yeah, we call all that together the innovation ecosystem. And so certainly AFRL is the Space Force's research lab. We have a concept called One AFRL, Two Services, which is meant to organize all 10 directorates in AFRL to support both the Air Force and the Space Force. And that concept will enable us to provide the tech needs for both of the services. Now, DIU and DARPA, they're kind of fellow innovators, and I love having some of that because it gives us people to collaborate with, and then the competition of ideas, and when you're in this kind of phase of development, is really powerful, where you can build off each other and try to come up with a better way of building a mousetrap as compared to these other folks. So I think we've got a good innovation ecosystem. And then the Space RCO and SMC, those are primarily, and the Space Development Agency are our primary transition partners. So after we get the technology matured, we give it to one of them to migrate into a program of record and actually have a sustained long-term capability for our warfighters. So all of those relationships are just super important to making sure that this innovation ecosystem works the way that it's supposed to and the way that we want it to. I will tell you, when I first got here, I was kind of surprised by, it's a little chaotic, compared to where I came from in a program office, where a program office, you've got a very systematic, defined process of how you get from this is my requirement, and this is you do your system engineering V, and you test, and you deliver at the end. And that works great for mature, once the technology is mature. But in this innovation ecosystem, it's a little bit, if you want to be successful, you have to have a little bit more chaos in the system so that the good ideas don't get suppressed and that they can actually bubble to the top quickly and get explored, and you can fail fast. And so that was one of the biggest surprises when I first got here, is how important that is and how it's different from the normal acquisition processes.
Yeah, and that's interesting. I'm going off my questions a little bit, but with the DIU, one of the things that I noticed there was they have their structure very much like a startup accelerator, right? Where they're kind of reaching out for ideas, and so you guys are structured a little bit differently, and so it almost seems like each organization kind of has its own culture in this innovation ecosystem that you mentioned. And then those all mesh well together, but they're all kind of speed matched for the culture that they work with, right? Like DIU is out in Silicon Valley, and then you guys are working with a little bit more traditional organizations. And so you're all kind of going the same direction, but you're kind of representing different cultures and different approaches, it seems like.
that is a really good way to describe it. And we have made great advances over the decades through, what some would call evolutionary improvements in technology, like the solar panels of today are so much better than the solar cells that we had 20 years ago. And that didn't happen by accident. That happened by AFRL working closely with SMC on, yes, we really need this, and this is what you could do, and here's a triple junction technology that enables new things. So that kind of evolutionary improvements to the components of the systems is super important, and that's the tech pull side. But you also have the push side when you have these new breakthrough and potentially game-changing technologies, and that's kind of what DIU is looking at in Silicon Valley is, what if we took that thing that is breaking through on the commercial side and applied that to our defense problems? And that's a really important part of what we do also. So I think your description is spot on.
Oh, wonderful. Well, it's interesting. Now, earlier you'd mentioned you'd work on the Airborne Laser Project, and that's part of the larger AFRL organization. And so, as I was doing research for this, when I was looking, it looks like the Space Vehicles Directorate, at least for quite a while, has been really kind of focused more on satellite technologies. But it also seems like that's starting to change with projects like the X-37. And so I'm wondering, we have Elon Musk and SpaceX. We have this just explosion of ideas and technology and diversity in space happening right now. Is that starting to take you guys out of more of kind of a focus on satellites into kind of a larger sphere of ideas?
I wouldn't say that the focus or the core competencies of Space Vehicles Directorate are changing, but you are seeing those changes at the AFRL level. So AFRL split up into these 10 different directorates, and each one has its core areas of technical competence and capabilities. And ours has been space vehicles and still is. But what you're seeing is a lot more collaboration and teamwork across the whole laboratory, which is very positive. And that's being driven in part by there was a Science and Technology 2030 strategy that the previous Secretary of the Air Force signed out, which restructured kind of our business processes so that to successfully launch a venture within AFRL, you don't have to sell it to the 3 different directorates and hope that they all agree it's a good idea to go forward. Instead, there's a much more corporate way to get your idea evaluated, and if it's a good one, funded. And so now, as the directorates, we are incentivized to go cooperate with the cyber guys and the sensor people and the materials people to bring the best ideas together. So you are seeing some different and very positive, good behavior, corporate behavior at the AFRL level that's helping us to better serve both the Air Force and the Space Force. But that doesn't change our core. We still have the same core competencies within RV. I think we're just using them in a broader way that is good.
Okay. And again, this goes off my questions, and I shouldn't even ask this. It makes me look ignorant. But one of the things, Pete Gerritsen helped me with these questions, as I should mention. And
I love that guy, by the way.
Oh yeah, no, Pete. He's
great thinker.
I cannot say enough wonderful things. He's brilliant, and he's motivated, and he is helping. He is doing so much for the community and for the Air Force and just for the United States in general. But so he didn't explain to me why the Space Vehicles Directorate is called RV. So I wanted to ask you about that. I know it's a simple one. I couldn't find anything online. It was like RV, space vehicles.
Yeah, they don't explain that very much, but the way it's set up is the R means research, and every one of the 10 directorates starts with R. So RI is research and information. RX is research in materials. I don't know where they got the X, but RV is research in vehicles, because
Okay.
S was already taken. So it just means research in space vehicles, and is how you get to the various acronyms. And I don't know why that's how they set that up a decade or more ago, but that's what the RV means.
Well, I appreciate your explaining that. Again, there are these little things as a civilian that I miss, right? And and it's just second nature to you guys.
I don't know how anybody would figure that out. I didn't know that either till I got here to AFRL, but now that's how it works.
Well, so I wanted to ask you again about the X-37, because that one's interesting. It just recently flew a mission for the Spider project, and I understand that you took up some experimental hardware for Paul Jaffe to study the concept of space-based solar power. I'm wondering, can you tell me a little bit about that project and what kind of progress, what kind of results they had with it?
Sure. So space beaming power from space is another one of those ideas that's been around for decades because it would be really great if we could do it. But what's happened recently is that we're finally getting the technology to a level where we actually think we can go build something that would be useful. And so, Paul, one of the key technologies is this wafer that directly converts the solar energy to the RF energy. And Paul Jaffe built an early version of that wafer, and we flew it on the X-37 to make sure it could survive in the space environment. And that is one of the key technologies. Now, in the SPIDER program that I'm executing here at Space Vehicles, Space Solar Power Incremental Demonstrations and Research is SPIDER. We're continuing to mature those technologies, and what we've done is we've decomposed from an operational system what are the key the critical technology elements that need to be demonstrated to enable that kind of a system. And these operational systems are very large. It might be 1,000 square meters of these panels that you need in space to beam significant amounts of power. So you got to be able to have large structures. You have to know where each of the little elements of the panel is. You have to have great efficiency in the conversion process. So there's all these critical technology elements that we are maturing one by one. And then the SPIDER, this phase of the SPIDER program will culminate in an on-orbit demonstration of power beaming where you will actually be able to on the ground see a light bulb glowing when your satellite goes over to prove the basic technology. And if that works, then we're confident we could scale to the larger structures that are needed to enable the operational concept. But energy and having energy on demand is something that is super operationally useful to our Department of Defense, and no matter which domain you're operating in. So the Army loves it, the Navy loves it, the Air Force loves it, both for the stuff that's in the air and the stuff that the operating base is on the ground. And we could beam to other satellites too, so that when they're in eclipse, you don't have to have batteries. It just enables all kinds of new operating concepts. So it's one of those big ideas that's out there. And again, we finally feel like the technology is there where we can actually build that and make it useful.
Yeah, and it's a remarkable experiment, and I think that the X-37 again, just in general, is a testament to how rapidly things are moving forward. I mean, just to stop and say, when you think about an fully automated space shuttle flying, on its own, to me, that's just remarkable. And it's just taken for granted, right? That the shuttle itself isn't even the interesting part. It's the wafer that converts the solar energy into the electromagnetic beam. So, that whole thing, I mean, it's moving forward so rapidly, Now, so in terms of the X-37 being automated, Major General Shaw has said that at some point the Space Force will be putting people into space. And when that happens, you guys will be designing the vehicles to carry them. So if they end up getting a rescue mission, will you guys be creating space vehicles for them to use? Have you kind of worked forward what that might look like, how that might work?
It is really interesting and exciting to envision, human presence in space and what we would need that for and how we would use that. And I think the answer to your question is no, I don't think it's that I'm going to be designing those things. And the reason is that there's so much commercial activity in that area. So this space renaissance is being driven by commercial interests and commercial activities. They are going to ensure that we have humans in space and on the moon and in Mars. And they are going to be the drivers of that. And so what my thought on that is that we in the military need to figure out how to quickly use that commercial innovation and that commercial technology in order to perform our mission. So I'm very interested in the military unique parts of humans in space, what those are, and then identifying those and then partnering with the commercial folks to ensure that they that we have opportunities to influence the design if we need to as we go along. But they're in the driver's seat, and I'm excited to let them drive. They will do it much faster than we in the government could anyway. So really, it's a great opportunity. For humans in space is a great opportunity for commercial and public-private partnerships, and we want to work closely with them, but I don't want to be doing that myself. I think that they are the better in the driver's seat with that technology.
Absolutely, absolutely. Well, I wanted to jump back. I should apologize. I should have asked this directly after the spider question. But so, China has also been testing space-based solar power, and they also have plans for lunar industrialization, nuclear propulsion for asteroid mining, and a lot of competitive space industries. And as we move out, they are looking at moving out as well. And so this is part of that great powers competition, I guess. I'm wondering, from that perspective, how are you guys helping the Space Force keep up with this competition?
That's definitely true. I mean, China has ambitious plans in all of those areas and are very strategic about their approach over decades of how to the technology development that needs to be matured, and we are too. So one of my jobs in AFRL is to be the art of the possible people. And what that means is these are things that we could do, and then those need to be intersected with the things that we should do. And so you got to have the art of the possible. That's great, but then of those things, what are going to be the most militarily useful? And those are the things, the technologies that we need to develop. And so we have a lot of strategy and planning that goes on between AFRL and the Space Force staff and the Space Force scientists to think through these various things and what we need to do and what our strategy should be. So one example that I thought was really cool, I just saw this last week, that Peter Gerritsen down at Air University came up with what he called this is not its official name, but Lunar Catan, all right? And it's just a way, like the settlers of Catan, to think through, okay, if you're going to settle the moon, what should your strategy be? And, what resources do you need and where should you locate them? And really thoughtful things. And then after you go through and play that game a bunch of times, you can start to realize, oh, this is a strategy that works and helps us be successful in that new operating domain. And then my job from there is, okay, if that's your strategy, what technology do you need to make sure that you're going to be able to implement the strategy that you want? So I think that all fits together in terms of thinking about the future and then planning for the technologies that will enable you to have a wide range of options in the future. And I think that the strategic plans that China has out there are good for us to study, just like you always want to study other people's ideas, and then we can incorporate that thinking and those ideas into our own planning and strategy, and that's some of the most fun stuff that we do at AFRL. Actually, I think is that the art of the possible and how would that play out in this kind of wargaming.
Yeah, and it is intriguing to look at all of this commercialization. So, now another area, I guess, is that I've heard that intelligence agencies believe that China's working on some weapons development programs as well for direct ascent and co-orbital weapons, as well as directed energy anti-satellite weapons. So, is that also an area that you guys are developing countermeasures or deterrents for?
Yes, we are very concerned about the threats that are quickly developing against our space capabilities. And the reason that those threats are maturing is because our adversaries realize how important our space capabilities are to our way of war, and they realize that if they could take those away, that could give them a strategic advantage. So of course we don't want that. We don't want them to see that there's any way to defeat our U.S. capabilities, because that's the key to deterrence, is thinking that there is not some special way. So we don't want space to be the special way that they pursue. So we are very concerned about those threats that are out there. And we have a number of efforts underway to mitigate those threats. For example, I've got right now a satellite called DSX, Demonstrations and Science Experiments satellite, flying up there with an 80-meter boom. It's the largest unmanned structure in space, and it is broadcasting very low frequency radio waves so that we can determine if that is an effective way to mitigate radiation in space. Because we learned in the 60s by accident that if you detonate a nuclear weapon in space, which is about the worst possible thing you can imagine, that it can have a very, I mean, we lost half of our satellites in the 60s because we didn't know what was going to happen when we did that. That is of concern today, as with North Korea and others threatening that kind of action. So DSX will, the physics tells us that these very low frequency waves will cause that radiation to be mitigated in perhaps in days instead of months or years, which is a really big deal. So that's just one way of mitigating that most severe threat that you can envision. But we've also got efforts to harden satellites against lasers, to just in general work on having more propulsion on the satellites, having more proliferation. So having thousands of satellites instead of just 3 is a great way, because then they have to take away the capability, they would have to attack a lot more satellites. So proliferation by itself. And then really, one of the most important things about deterrence is attribution. So just having space domain awareness so that we can know who's doing what up there. In the realm of diplomacy and the stuff outside the military, that is super foundational and important to everything that we're doing in space. So I think I would say our whole technology vision is guided by concern about those threats that you identified, and just what are the right appropriate ways to mitigate those so that we can deter our adversaries from actually using those capabilities.
Yeah, and again, I know this is all part of that brown role that we did. The brown water that we talked about earlier, the brown water role, and so it's near Earth LEO based stuff. So another thing though that you guys are looking at is the blue water role, and you're working on the Pathfinder satellite to find and track objects in cislunar space, as well as those orbiting the moon, in what Pete actually called the cislunar highway patrol. I'm wondering if you could tell me a little bit more about that project.
Sure. So that was one of the projects that we selected as our next flight experiment on the blue water side of things, as you say. And the reason for that is that so the area of operations for U.S. Space Command has no upper limit. Okay, they have an assigned area of responsibility, and it has no upper limit. So what that means is that wherever we see our adversaries operating, or wherever we have commercial activity going on, the Space Force needs to be prepared to defend our interests in those regions. So we have a lot of adversary and commercial activity headed to the cislunar sphere for commercial activities and tourism and all kinds of stuff. So the Space Force is going to have to protect and defend the celestial lines of commerce, or the space lines of commerce. So I need to develop the technology that they're going to need to do that. When we started to look at the problem of operating in the cislunar sphere, there are a lot of technical challenges. So we love technical challenges. We're the research lab. But some basic things, like how do you even specify what orbit you're in and determine your orbit? If you're near the Earth, it's really simple because you just have the Earth's gravity and then the mass of your satellite to worry about. When you're up there at the moon, you got the Earth's gravity, the moon's gravity, and the orbits that the satellites follow are more like drunken sailors stumbling around. It's much harder to calculate them and figure them out. There's a lot more uncertainty. So even specifying what orbit you're in up at the cislunar sphere is a technical challenge that we're eager to get after. Size, the moon is 10 times higher than the geobelt. So we've traditionally been interested in the geobelt as the top of the area of operations, but now we've got 1,000 times more volume that needs to be searched to find activity that's going on there. And then there's something called that we have nicknamed the cone of shame. All right, so the cone of shame is the area right around the moon, and it's the area that you cannot maintain space domain awareness from ground-based telescopes, because the moon is so bright. And of course, you can't see through the moon. So we like to joke that the moon is very bright and opaque. So if you want to see what's happening on the other side of the moon, and you want to be able to see what's happening in the cone of shame, you need to be able to you need to have space-based assets up there. And that led us to CHIPS. So CHIPS is the Cislunar Highway Patrol System, and it is a small spacecraft that is going to operate around the moon and the Lagrange points in order to maintain awareness of the activities that are going on up there, and honestly, just in general, get us used to operating in that AOR, so that as the Space Force needs to move into that AOR, they'll have the technology that they need to be able to do that. So that's what CHIPS is.
Yeah, and and that's an important point because NASA, they want to go back to the moon. The Artemis program wants to land the first woman and the next man on the moon in 2024, and then they're also looking at the Lunar Gateway Station, which is planning to accompany those efforts. So, are you involved with those at all? Or are you? And I'm sure that you have to look at how the future support those as well, right?
Yeah, we do have very close collaboration with NASA in some areas, especially on the technology. And the technology that works for our mission is often very similar to the technology that works for their mission. So the two organizations, the DoD and NASA, have different missions that we're performing in space, but often the core technologies are the same. So there's lots of opportunities for close collaboration on the core technologies. And as we figure out how to navigate and communicate near the moon, of course, we're going to work closely with NASA, who also knows how to and needs to navigate and communicate near the moon. So I think there's lots of opportunities for that. Another example is in the standards side of things. NASA has developed a great standard for optical communication in space. We don't want to invent a different standard than the NASA standard. We want to follow, and that is a very important technology for us, but we want to just adopt the NASA standards for that particular technology. So in technology standards, even operations, and launch and things like that, it makes a lot of sense to work closely with NASA on many of these problems.
Yeah. Well, and I definitely appreciate your describing that. I mean, again, things are moving so rapidly. I mean, the moon, and then you've got Elon Musk, who's already talking about going to Mars. Have you guys looked at Mars technology yet, or is it still kind of in the early stages?
Well, AFRL actually has 3 different technologies that are flying to Mars right now on that NASA mission. So yes, we have thought about the kind of technologies that we're going to need to operate even beyond the moon. I do think that the public-private partnerships are going to really be key here, because again, I don't see the U.S. government, whether it be NASA or the DoD, as in the driver's seat for driving these missions to Mars. It's commercial activity that is driving this space renaissance, and so as a different model for us, might be just as exciting as 1960s, but it is different from 1960s in that the government is not doing all this stuff ourselves, and we're not really in the driver's seat on that. So we do need to focus on how do we work appropriately with the commercial folks that are doing these things to make sure that we get the synergies that we expect, even though they're driving. And some of the ideas we have there is, even when AFRL can't provide like direct funding to support these commercial activities, and they don't necessarily need funding, they're pretty well privately funded, some of these bigger activities. But we have agreements like CRADAs, where we can provide test capabilities and we can evaluate their technologies, and we can provide technical advice, which is very valuable in helping them operate on a faster timeline and stuff. So those are the kind of things that we're trying to put in our toolbox to help work with the commercial providers as they drive us into this second space renaissance.
Yeah, that makes sense. Now, one of the advantages that you have, because I mean, being part of the government and having access to all those decades of research, is probably in propulsion systems research, right? That's something that the private sector, I think, is probably a little bit behind on. They're still focused on rockets. They've done some brilliant things, self-landing rockets. I mean, that's genius. But have you guys looked at next generation propulsion systems? I mean, as we get into cislunar, as we start to get out towards asteroids and Mars, those are larger distances. They're going to have to move faster. Have you guys looked at stuff like fission, fusion, beamed energy, or any other kinds of advanced propulsion to be able to just basically move faster, use less fuel, have more range?
Yes, to all of those things that we're looking at them. On the commercial side of things, we've got 137 launch startups now operating at various different stages of maturity and stuff. So getting from the Earth up into space, think of that as pretty much a problem that's going to be solved by some of these commercial startups. But in space propulsion, that is also super important to the future operating concepts, because again, if you're talking about 1,000 times the volume of space that we need to be able to operate in space propulsion is really important. And there have been some really important developments in that area, like the ascent green propellant that was developed at AFRL out at Edwards Air Force Base, now been tested in space. It's higher performing and not dangerous when you're assembling the spacecraft. So what's not to like about it? So that's on the chemical side of things. And then electric propulsion, they've seen huge advances, and that enables us to actually contemplate launching satellites with 6,000 meters per second of delta V and numbers that we would have thought were crazy in the past. So some of these examples in advances in in-space propulsion have been really important. In terms of fission, fusion, things like that, solar power is great for the vast majority of our Space Force missions. So that's still our primary focus. But what we're looking at is, hey, are there some new missions that could be enabled by some of these new power sources and these new power systems? And to that extent, those are very interesting to us. So, I want to sort of maintain. I'm not going to be the leader in nuclear propulsion until I see the military need for that technology, and that's one of the things we're looking at. But I sure want to be the partner and the follower if someone else develops that kind of a technology too. So I do think they're in propulsion as well as in a lot of the other areas. There's been a lot of exciting advancements recently that will enable us to do new things in space, and really that's kind of one of the main themes that I see is just we're doing a lot of things we are not only doing the things we've always done in space better, but we're now envisioning doing a lot of new missions in space that weren't before either technically possible or weren't maybe cost effective to do from space, but now have to be done from space. For example, look at a lot of the missions that are done by large aircraft today in our Air Force. Those large aircraft are not going to be able to operate in a denied environment like we envision. So, you're either going to have to switch to small stealthy aircraft or maybe to spacecraft. So it's exciting to look at the things that we can do in space that we might do in the air domain today that we could move to the space domain because of some of these technology advances. Those new missions, I think, are going to be some of the most important breakthroughs that I hope AFRL can be the thought leaders in bringing some of those ideas to fruition.
Absolutely. Well, Eric, I really want to thank you again for your time. And let me close by asking, what comes next for yourself and RV? Where can we expect to see your work next in upcoming headlines?
Well, I hope some of these new missions that we've talked about really do pan out. I think there are some really transformational capabilities that are right in the pipeline right now, percolating along. And if we were to talk 5 years from now, I hope 2 or 3 of them, maybe 10 of those have failed, but 2 or 3 have changed the world and that's really what we're trying to do. And the reason we want to do that, again, I mean, just to come back to what our mission is my job from the AFRL side is to ensure that the Space Force can deter destructive conflict in space. And I want them to be able to do that tonight and also 10 years from now. So I'm the guy who's especially focused on 10 years from now, making sure that we are always able to maintain that technology edge. So if we talk in 5 or 10 years, I hope we can still say we have not had destructive conflict in space. That is our #1 goal, and that's why we're working on all these great technologies.